Great. Ooh, that's much more impressive than it used to be last year's. All right. Well, I'm Jean-Macq. I'm going to talk about MLO today during this session. I just would like to start by thanks everybody to vote for my session and be today in front of you. And I hope you're going to have a good time as much as I have a good time to prepare that. So we're going to talk about MLO and a bit more specifically about MLO through the iPhone 16 prism. I hope you like French accent. Good. So I'm going to talk about two scenarios, and maybe they will soon familiar with you. This one, you are in a car, you have two queues, and you don't know which one to pick, because if you go on the left one, the right one's going to move. If you go on the right one, the left one's going to move. It's a dilemma that we all faced once, at least. I don't know if you ever test a slackline. That's a funny kind of thing, kind of rope that you put on the tree, and out of the tree, and you try to walk on it. That's pretty tough. So these two scenarios are real life scenarios. And if you change a few things, if you allow to switch very fast in between the line for the car and be able to switch exactly where you need to be, or if you can add a new rope and use that rope with your hand to be more stable and move faster, that are MLO-like solutions in the real world. I just want to mention again also that once you have an option as a car to be able to move fastly in between the lane, or like the dog, which is able to walk on two or use two lines at the same time, it's not because you have the option that you have to use it. And what I mean by that is that the cars might be able to move very fast, and sorry, the timer is not correct. Okay. It's 30 minutes. Yeah. Yeah, sorry for that. So yeah, what I was stating is that it's not because you have the option to do it that you will do it. You might be very stable on one line and not use two. And that's a bit like old Wi-Fi device will do with MLO, is that it's not because they can do it, they will do it. It's up to the subject, it's up to the device to decide if it goes to use MLO or a specific MLO mode or not. And it depends on its abilities, of course, and the way its mindset is set. We're going to talk about that a bit later on, just as an introduction. So now, what I want to make sure is that everybody is familiar with MLO, and we are going to go through a few points. First, everybody who has heard about Wi-Fi 7 knows that MLO is about using more than one band at a time, which is correct, but can be a bit more deeper than that. So if we have a deep look, there is actually two kinds of MLO mode, and each has two sub-modes. So the first one is a MLSR. So here you have a multi-link single radio, right? So the point is that you have a single radio on the station, only one radio here. That's going to allow you to talk on one link at a time. And then the device will be able to change of link over the time based on specific condition. It is the most basic, and this is default mode for MLO, meaning that each Wi-Fi 7 device compliant with MLO connecting on access point where MLO is enabled will use that mode. Then we have an enhancement of this mode, which is EMLSR, for Enhanced Multi-Link Single Radio, which makes sense. So we are still on the single radio, right? Now, the big difference is that we have some improvement, allowing the system to be able to listen to two links at the same time. So basically, the radio will have two spatial streams, and one stream will be dedicated to one link, the other stream will be dedicated to the other link. This way, the system is able to listen on both links at the same time, and is able to move very fast, packet by packet decision in between the band, which is very different from MLSR, and which provide great benefits. What kind of benefits? Well, here a quick test that was done with the Pixel 8, just to let you know. And so basically what was done is that we have packet coming from a system that's going to measure latencies. And in the blue, you have the 5 gigs. In orange, you have the 6 gigs. If we put some interference in 6, you're going to see that all the packets move basically on the 5 gigs, and the 6 gigs is less used. If you go back to the normal state, you come back. If you restart, it does the same. So the system will automatically adjust to the interference to be able to switch the packet where it makes more sense. It's an example for downlink. This is the one for uplink. And basically, this gives to you a difference of, it's provided much more better latencies. So in download, basically, you are able to move from almost 500 milliseconds to 22 milliseconds. So it's up to 20 times faster. And in upload, it goes from 58 to 3 milliseconds. So basically, eMLSR does do a big difference. Now, we talked about MLSR. We're going to talk about MLMR. So what is MLMR? It's basically multi-link, multi-radio. So this time, you have multiple radio here set in front of the link. The first mode is NSTR, for non-simultaneous transmit and receive. Basically, as the name mentioned, you can use only one link at a time. It is mostly used, defined at the beginning for when you have to communicate across 5 and 6, because you could have interference in between the two if the physical isolation is not good enough. It's also one of the modes which is not as well defined as the other one in the standards. And in the Wi-Fi 7 institution test, the band test, you mean the place where you stamp a device as Wi-Fi 7 compliant, there is no specific test for this mode. The only reference is a field indicating that STR is not supported if it's on. And we're going to see that a bit later. And so what is STR? STR is for simultaneous transmit and received. And of course, it allows TX, RX operation. It's also the most hungry implementation, power-hungry implementation, since it uses 2 radios at the same time and communicate over the 2 radios at the same time. And it is usually supported by high-end device, sorry. 2 more concepts. If we go on multi-link device, we need multi-link. We need MLO to be able to have a new Macq to be able to overglobe the other link. And so we're going to have this upper layer for the Macq layer, where we're going to manage authentication, cost, keys, and we're going to have sub-layer, lower Macq, to be able to access to the media itself. One more point, if you have several links, it means that you need to identify it, and for that there is something named link ID. So link ID is just a value that you give to a link to be able to see it, and as a ruckus, we're going to use for the demonstration here, basically we had decided that number 1 will be assigned to the lowest band, and then you increment by 1 each time you go upper. So if I take one example, 2.4 and 5 is going to be 1 for 2.4, and 5 will be 2. If you do for the 3 radio, it's going to be 1, 2, 3, 1 for 2.4, and 3 for 6. What can you expect from a Wi-Fi 7 device? So if your device has been certified Wi-Fi 7, it means that as an access point, it must support STR. And it must be able to work with eMLSR, sorry. As a station, first, it must support the basic mode, so the MLSR we talked about. And if it supports more than 2 spatial streams and channel up to 160 MHz, it has to support eMLSR or STR. Could be both, but has to be at least one of the 2. So clearly, for high-performance device, we can see there is a focus on eMLSR and STR. So once we have 2 spatial streams and 160 MHz, and that's what we're going to focus also on the coming slide. All right, so we talk about MLO, but we haven't talked yet about iPhone 16. And we need to understand exactly what it supports. So if you want to identify the capability of the device, first thing you can do is to check the vendor specification. So if you go on an iPhone website, you will see, Apple website, you will see that it supports up to 160 MHz, and it supports 2 spatial streams, which means, if you listen to me a bit before, that it must support STR and or eMLSR. How to figure out that? Well, you just need to set up some tests, demo environment, where you're going to expose your station to access point where you have MLO in 2.15, 2.16, 5 and 6, and the 3 band. And then each time the client will send an SSN request, you're going to pick that SSN request, and you're going to see what it looks like inside, because the device will inform about its abilities, and so you'll be able to map and identify clearly what it does or what it doesn't. As a side note, maybe if some of you has this question, if we are using several bands, just be aware that the station will use one of the bands to send the association request. There is no specific rules there. It could be used any of the 3. So you have to capture the 3 band if you want to make sure you don't miss it. Well, you know how you set up the context to get the information. Now, you need to have a look on what you should look at into the association packet. Association frame, actually. So you are going to look for the information element named multilink. And in it, you're going to look for those specific bits, so EML capabilities and MLD capabilities. If the EML capabilities is set to true, you're going to get this subsection that you can have a look and see if yes or not the device supports EML-SR. Then, if it supports MLD capabilities, you're going to have this place here where you're going to get a very important information. It's a maximum number of simultaneous links. When it's set to 1, it means that you can support up to 2 links. So basically, the value here is a bit value. So 0 means 1 link, 1 means 2 links, and 2 means 3 links. And then the final thing you're going to have a look at is the NSTR bit to see if yes or not the system supports STR. Let's practice. So here, an association. What we can see here? We can see that we are on channel 36, meaning that we done a capture on 5 gigs, and it's a link ID number 2. Why 2? Because we are on channel 2.4 and 5, and so 5 is upper one, so it's 2. Then we can see that it does not support EML capabilities, meaning that at this stage, with the iPhone, and the test here was done with iPhone iOS 18 and iOS 26 beta, EML-SR is not supported at that stage. Then we check for the MLD field, which is true, and then we have a look on the number of maximal simultaneous links. And it's 1, meaning the system supports up to 2 links. Last things we have a look, it's the link ID on the bottom here. So it's a link ID for the link ID 1, which makes sense because we are currently connected to the link number 2. So 1 is 2.4. And what you can see is that the NSTR link pair is false. Conclusion, we do support STR on that mode. I won't repeat that for 2.4 and 6 gigs because it's exactly the same and the conclusion are the same. Now, we are going to quickly have a look on the 5 and 6 gigs. So if we do the association here, the beginning is quite the same thing, so no support of EML-SR at that stage. And if we look at the maximum number of simultaneous links, we have the value of 0, which means that the max of simultaneous link is 1. And which, let's believe that we cannot do STR because we need two links at the same time. And if we have a look on the link ID, the 1, you will be able to see that NSTR is true, meaning that it does not support STR in that specific mode. When I say mode, I mean in the 5 and 6 at the same time. And then there is a last test with a 3 radio, which is a bit different. So again, the beginning is the same. So we have the channel, we don't support EML-SRs, we are an environment where we support up to, so the simultaneous link is 1, meaning that we support up to 2 links, right? And unlike before, we have 3 radio. So because we have 3 radio, on the bottom, we don't have only 1 profile, but we have 2. Profile count 2. And it's for link ID 2 and 3, since we are currently on link ID number 1 in 2.4. So if we have a look on those specific per STA profile, what we can learn? We can learn that on the first one, link ID is 2, meaning it's 5 gigs. And it says that NSTR is true. So you could believe that NSTR is not going to work for any link with 5 gigs, but there is one more information here, which you need to look at. It is the indication bitmap. Here, the indication bitmap is 08. If you try to understand that, well, 08 in decimal become in binary 00001000. Let's remove the first one and put some colors. And then you have to match that link ID 1 will be the orange, link ID 2 will be the blue, link ID 3 will be the red. So here, what the system tells you is that, well, with the link ID number 2, you're not going to be able to do STRs with the link ID number 3. So basically, no STR with 5 and 6, and then STR is supported with 2.4 and 5. For the second profile, it's exactly the same thing, except that here the bitmap value is 4, and so we are pointing the link number 2 from the link number 3 to say that STR cannot work here with that one. So we just profiled the iPhone 16. It does not support EMSR today. It supports STR if you do 2.4 and 5, if you do 2.4 and 6 with MLO, and it does support 3-band MLO association. Right, we know who it is. Now the next question is going to be how and when can you use that? When I say that, I mean STR. So as we talked a bit before, when a device has ability to do something, it doesn't mean it will have to do it. So if my iPhone 16 can do STR, it doesn't mean that it will do STR every time. And so the question is, when is it going to use it or not? The fact to be able to use a specific mode of MLO or not is fully dependent of the client itself and the way its environment is and its own algorithm. To be able to understand that, to be able to clarify what and how does STR is triggered, we need to set up many testing environments and simulate several things to be able to understand what triggers the activation of STR. And so here in this case, this work was conducted by the Request Wire System Performance team, where the leader is in the room today and will do a session. And what they discovered after a lot of tests is that to be able to do STR with an iPhone 16, to be able to trigger it, of course, you need to use the MLO link we just mentioned before. But then you need to have at least one traffic prioritized. What does that mean? It means one traffic with the TIDs in video or voice mode. Or, so in this case, we're going to use FaceTime for the test in a second because iOS automatically sets FaceTime as voice. It could be other things that could be prioritized the traffic. So for instance, if you do have an iPhone and you start a game, you can see that the game mode is on. And usually what happens is that when game is mode on, then the traffic from that game is prioritized. So that was the second condition, getting a traffic prioritized. Now the latest one is to be sure that at the same time, we're going to have some ad hoc communication from the device to something else at the access point. It could be through AWDL, you know, it's this protocol from Apple to do AirDrop, screen sharing. It could also be operation action, such as Wi-Fi scanning. And so if you have these three at the very same time, then the iPhone will trigger the usage of STR. To be able to test that, see it, measure some information, latencies, well, they have set up, the team has set up an environment into an anechoic room where they set a switch, a laptop, a MacBook Pro, and a Ruckus R5770, so a Wi-Fi 7 access point. Then we connect the iPhone Pro to the Ruckus R770 into the 4 and 5 MLO. And we generate the traffic from this device here, up through to internet, to another device remotely set. to have a FaceTime communication. We also set up an AirDrop link in between the device and the MacBook. And lastly, we activate Steam on the laptop here, and we activate Steam Remote Play on the iPhone. Here, why do we have Steam? And Steam is set with the background priorities. We have that because Steam provides some real-time latencies, and we have some kind of video to have an impact, visual impact on the performance. So as you can see here, there is a way to display the latencies that is set when we use Steam. The result is the following. If we have only Steam, then in 5 gigs, we're going to have latencies about 40 to 50 milliseconds and a good video. Once we have Steam, AirDrop, and FaceTime, well, we are going to have huge spikes up to 300 milliseconds of latencies. And once you activate the 3-flow plus STR, because you activate the MLO from an access point perspective, then you'll see the latency spike drops. It's not perfect from a video perspective, but it's much better. And there is something funny with the FaceTime traffic. The funny thing is that the traffic of FaceTime is spread across the 2-band, but not in a random way. So the way it's going to be split up is that in 5 gigs, you're going to get the Steam, you're going to get some AirDrop communication flow, and then for the FaceTime, the data coming from the iPhone 16 will be, so from the iPhone 16 to the other iPhone will be on 5 gigs, and the data coming from the other iPhone to this iPhone that we are measuring is going to be on 2.4. So both sends have been split on 2 different bands. Now the question is to get a bit more information about latencies, not just this data that we provide here, which are good, but not very accurate. So we are going to use right now byte blowers. Byte blower, what it is like an iPerf system that generates traffic, but is able to measure latencies of this traffic with a very good accuracy. So we have the very same setup that we have on the previous test in this lab, except that we added this byte blower system here. And we added a client of byte blower into the iPhone. And then we do generate a bidirectional 4 megabit stream, prioritized as voice video from the byte blowers to the system here. And the result are that, I'm going to make it quickly. Without MLO, we have 339 milliseconds. With MLO, we can go down up to 62 milliseconds. So there is a huge difference in between the two once MLO is activated. And so, yes, there is a real benefit to use STR in such condition. Just one word about this 99 percentiles. So the measurement we are doing here is not the average. It's basically, we take all the first 99% of the traffic, and we can say that the latency is not about this number of milliseconds for the first 99%. That's what we are measuring here. All right. It's up to clarify, wrap up the session. So, what do we know? What do we learn? First, there is 2 high-performance modes in MLO today, which are MLO eMLSR and MLO STR. The basic MLSR is just the basic mode when an access point, as a device is connected to an MLO access point. Then, we know that with an iPhone 16, we support STRs across the band 2.4 and 5 and 2.4 and 6. We know that at this stage, iPhone 16 does not support eMLSR. And we know that if we want to trigger STR on an iPhone, we need prioritized traffic and other communication, such as AWDL for peer-to-peer application, AirDrop, screen sharing, and or some specific operation action from the device, such as Wi-Fi scanning. The other point that I learned during this session and during the time I took to prepare this content is how MLO is complex. And it can be confusing. And it's going to be a topic for so many, many future discussions about that, because MLO is going to be something that we're going to talk for a long time, and they're going to generate a lot of conflict of, yes, I agree on that, no, I not agree on that. I can tell you that. All good. Thank you very much to Pete, Mark, Siddharth, and Andre for helping me set up this deck. Thanks to all of you guys. Thanks for your time, for listening to me, for voting for me. I really appreciate that. You are a great guy. And great vendor session Wednesday. Don't forget that. We have some good stuff for you. Thank you very much.